And welcome back to another episode of Containers from the Couch. You might see I'm in a slightly different area today, not usually in my home office. I'm actually in a completely different country. And it's a first for me because it's the first time I've actually done this Containers from the Couch, or an episode of Containers from the Couch when there's light outside, because I'm usually doing this much later in the evening in my time in Israel. And there's kind of sun outside in gloomy, overcast Toronto today. So we have an interesting episode today, and I would like to introduce our first two guests. Of course, our only two guests is Rudolf and Gunnar. So if Rudolf, would you like to introduce yourself, please, and tell us who you are, what you do at AWS?
Yeah, absolutely. So my name is Rudolf Potuchek. I am a product manager technical for external services, which means I get to talk to customers like yourself, ideate around what you would like to see in a service, and translate that into something that our team can build and design on your behalf. And as a result of this, I'm here to go and listen to what you have to say.
Awesome. And we're here to hear you as well. Gunnar.
All right, thank you, Mish. Thanks for having me. So I'm Gunnar Grosch, developer advocate at AWS, based in Sweden, in the Nordics, and I focus on hopefully inspiring AWS users in different ways. And a lot of my focus is on resilience and the topic of today.
Awesome. And for those of you who do not know me, my name is Mesa Casing. I'm a developer advocate with the ECS service team located out of Israel, today in Toronto. And if by any chance you're at the Toronto Summit, which is happening in 2 days' time, please say hello. I'll be there as well. I'm going to be delivering a session. And now that's out of the way, Rudolf, what is resilience? I assume that's something to do with how good we are, or how good our systems are, but maybe you can give us some more information about how we look at resilience within AWS.
Yeah, resilience is something where you will probably find many different definitions for resilience, but in the simplest sense, it is the ability of a system to withstand unexpected turbulent conditions and to continue operating within whatever you consider to be normal. And I've just brought up here the slide, really just focus on the idea that AWS is amazing at maintaining resilience, but there's obviously only so much we can do. Sometimes even we have problems. And then there's a piece that you can do to make your experience better. And so resilience is fundamentally, we are trying to get you to the point where you can sleep at night, right? I mean, I'm assuming you're technical. So from a selfish perspective, you presumably want your systems to be resilient enough that you don't get that wake-up call at 2 in the morning. But I know this is a bit of a marketing slide, but I just like the aesthetics of it. Beyond the purely technical, there's a lot of money involved in resilience. If you take an outage, of course, there's the money for the people who have to fix it, but then there's money that you lose in revenue, millions, maybe billions of dollars. And then there's the cost to your brand for people not coming back. So in a nutshell, that's what resilience is and why you would want it.
So, of course, as we said, there are a lot of people here in the audience as well, but I did a resilience kind of day within AWS in Israel not so long ago. And there's a difference between reliability and resilience. Because resilience is the fact, you say, of how your systems recover from failures. And what is the reliability part here?
I think we hear different ideas and different definitions between resilience and reliability. We can try to build systems that are as reliable as possible, but in the end, everything fails all the time. And we just need to prepare for that. And so really what we want to show you here is how to build systems that are not just reliable, but also resilient, and how to do that in a fashion that is safe, because obviously you're only going to learn about the bad outcomes when the bad outcomes happen, and we don't want that to happen in a way that impacts customers. And so we're just trying to build a service for you and build systems for you that allow you to find all of those bad things in non-impacting ways and to learn from them and to improve them. So basically go away from the natural engineering cycle of having an outage, being woken up, trying to figure out what the problem is, patching over it, and never really having the time to systemically fix a problem, towards a situation where you can do this mindfully, where you can start from a hypothesis, from a non-steady state, start with a hypothesis of what might be safe for your system, impact the system to that level, see whether you were right, and if you find anything that's not quite as great as you thought it was, go and improve it, and then keep doing it in a way that doesn't impact your customers.
And you mentioned the fact that we do this as a tool, but I understand this is a service, which you call fault injection simulator, which you're showing here.
Yeah, exactly.
So kind of doing these kind of experiments and these tests as part of your infrastructure?
Yes, so it is part of the infrastructure, but you can use it for a lot of your software problems as well. So obviously, we are a cloud provider. Obviously, you will be utilizing us predominantly for infrastructure. And so a lot of the failures that you would want to experiment with are infrastructure failures. How would your system react to infrastructure failures in AWS? And part of the issue there is that it's not terribly hard to break things. It is fairly hard to break things in a way that are safe, and that isn't a lot of overhead for that. And so we've basically built a tool that allows you to use IAM to go and have clear permissions management for who can break things, and to have an API for it so you can trigger it, to have safety features. So if your hypothesis was entirely wrong, you can close the loop with a CloudWatch alarm. And if the alarm goes off, then your experiment just stops and returns to a normal condition. And then we're striving to make this as seamlessly integrated into AWS as before, which is what Gunnar is going to show you shortly about how to impact containers. We previously had a solution where you could install container libraries in EKS, and now we've added something where you can do this natively. So now you have less installation required in EKS. Now you can do more in ECS. And in the process, we've removed a lot of the undifferentiated heavy lifting so that you can just focus on the experiments more than on the mechanics of how to build the experiments.
To me, if I can just jump in there, everyone who knows me know how excited I got when AWS Fault Injection Simulator was launched, because a lot of the things I always heard when it came to chaos engineering was that it was quite hard to get started with. You had to find different tools or different scripts and manual processes to be able to actually do it, and then to be able to do it in a safe way with these automatic rollbacks and safeguards like Rudolf mentioned as well. That's kind of tricky, and it in many cases perhaps made things less reliable, less resilient to failure, because you were doing things that needed to do a bunch of heavy lifting basically to be able to do those experiments. So I think that's one of the key parts that AWS FIS brings, this easier way to get started, and a way to get started that is a lot more safe in the way that you practice chaos engineering.
And this slide doesn't show that. This slide focuses on a lot of the purely who has access and who can do what aspects of it. But another part that people often don't appreciate is how much in an outage scenario like this, or in a simulated outage scenario, we have to focus on recovery under catastrophic situation. What would happen if you're running a script that disrupts your AWS infrastructure, and while that happens, AWS is actually experiencing some kind of event? Will you recover from that? And that is very, very hard to do. And this is something that has been a core thing that we've built into Fault Injection Simulator. There are some really extreme safety measures in here to ensure that if anything in AWS fails, we recover, and that at all points we keep you as safe as possible, definitely in ways that you probably couldn't script yourself.
So I think we're going to go into this in a few seconds, but I have been going around somewhere across the world delivering a session called Chaos in Containers, specifically speaking about why this is a difficult thing to achieve. I know the answer to that, but I'd like to hear, okay, we've heard about chaos engineering. We know what Netflix does with the fact that the Chaos Monkey, Chaos Gorilla, whatever they did, and there's other tools, third-party customers and partners of ours, for example, Gremlin, which do these kind of things. But why is it so difficult to do this in a container environment?
I'll give my opinion and then I'll get Gunnar to comment on it. I think it's difficult in a container environment because if you follow, very puristic approaches to containers, then that container contains nothing other than the one task that you want to be running. And at that point, if you want to inject any failures into that container, how do you do that? How do you log into the container? How do you instrument it with things? And now you have to make trade-offs. Do you want to have the instrumentation in a container the whole time? Do you want to inject it just for the run? And then how do you do that with the worker nodes? And probably the hardest part of it, what if you don't want to run Kubernetes? What if you're running in a managed service like ECS, where you don't even have access to the worker nodes and you want to inject faults into those? And now you have to really work pretty hard for workarounds, where now what we're going to show you makes that a lot easier.
Okay. Gunnar, you have anything else to add?
No, I think Rudolf is spot on there when it comes to that. It's a matter of we constantly tell customers in many cases that we want you to use the more managed services, and the more managed the service is, well, the less they can actually touch what's underneath. So then be able to inject faults into that environment, it becomes tricky for the end user, for the customer. So having the ability, like Rudolf said, to be able to do that on a different level than what the customer normally has access to, I think that's the key to doing chaos engineering experiments successfully in container environments.
And from this fault injection simulator, so the FIS that we have, AWS FIS, it's not only for containers, correct? It's also for other services which we have within AWS. You can use the same environment, the same permissions, the same methodology to do this as well, correct?
Yeah, absolutely. And I've not included that. Like, I brought a list of things you can do with containers, but I didn't bring the full list of other things. You can run faults in AWS directly. So anything, if you need to interact with APIs, you can build those directly, and we have some documents for common ones people want to do. If you want to inject failures in EC2 instances, then you can do that as well. And then prior to what Gunnar is going to show you right now, we also had integration with Chaos Mesh and with Litmus, which are chaos testing frameworks that are designed to run in Kubernetes.
Awesome. So Gunnar, you want to show us how this works?
Is it time? Let's do it. Yeah,
cool.
Let's switch over to my screen share. All right, so this is the AWS Fault Injection Simulator console. It looks like most other consoles, I'd say. So it's first step in getting started is that it is a familiar interface to get used to. And it contains a few different parts that we'll look at, but the key component that we need right now is an experiment template. And the template is where we then define our experiment and the targets that we are then targeting with the actions that we use. And these templates are, just as the name suggests, they are meant to be used not only once, but you can use them over and over again to run those experiments multiple times. And that's definitely a key part in resilience as well, doing things continuously. We talk about continuous resilience because what happens right now and how the system works right now, that might change over time. So let's simply start out by creating our first experiment. So I'm going to create a new experiment template. And we're doing it in the console right now. We can also do this through the CLI, or we can also create our templates in JSON or YAML as well. And of course, with the help of CloudFormation or CDK and so on. So first off, we're going to do an experiment now. I guess we'll start out with the most basic of chaos engineering experiments, which is to terminate something. So what we'll do is simply add a description of terminating and spell it to terminate instance. Then I'll also give it a name to be spell instance. There we go. Yep. Now we have the first part. Then we need to add our actions. And actions in AWS Fault Injection Simulator, we have a bunch of different actions we can add. And these can be one single action, we can have multiple actions both in sequence and in parallel, and then create like a timeline of the faults. Because as we probably know, when a fault hits one of our systems or applications, it's usually not just one thing that breaks. It can be multiple things. We can have a perhaps gradually increase in latency, and then eventually a process stops or similar. And we can then create that list of or chain of events, basically. But now, keeping it simple, first time, we're just going to do one action. So giving that a name as well. And then I can select the service category. In this case, we're going to target an EC2 instance. We'll get to the containers, I promise. And then I can select the action type. Many containers run on EC2 instances, so I think we're still...
I think all of them do eventually, but that's okay.
Exactly. So, like I said, we're going to terminate an instance. And that gives me the option to then add multiple actions and so on as well. And they can start after each other or simultaneously. We'll save our action and then move on to the target section. And here we then get the option to specify our AWS resources that we want to target with this. And we can then simply select a resource, one of my running EC2 instances in this case, or we can make use of resource tags, filters, and so on. In this first one, let's then switch to the EC2 console and check. We have a bunch of instances running. Let's make use of... Oh, this is going to be interesting for me to be able to copy paste. All right, so I'm going to use one of these. I'm going to copy the key. In this case, I want to target a specific stack. So we're adding a resource tag. And then the value in this case is that resource tag value. So now I'm only going to target instances that match this tag. I can also add filters. For instance, that I also only want to target running instances, which is, of course, more interesting in this case. But a filter could also be other types, for instance, the availability zone of the instance and so on. And then I have the selection mode, where I can then choose to target all of the instances that match my resource tags in this case, or a specific count or a percentage. In this case, let's set that we want to target one of the matching instances. And then save. So now we have an action, we have a target. Then, as Rudolf mentioned, it's about doing this in a safe way. So we need to have an IAM role that allows us to run these experiments. And I've defined one already, so we're going to use that. But with the help of that role, we can then limit what type of with us, well, the regular type IAM policy, we can limit what type of resources we can target. In this one, I specifically have added that we can only target instances that has FIS ready set to true, a tag, basically.
So it's that granular. You can, in other words, make a role which has a specific thing for a specific environment to target only that.
Exactly.
So you don't, by mistake, run things in environments that you don't really want to mess up in production. Yeah. Cool.
So about, once again, being safe in the experiments that we run. So now we have our IAM role. The next step is the other part of safety, which is limiting the blast radius. So when we run an experiment, we can then select to have a stop condition. And that's optional, as it says, but it's definitely something that we recommend. And these are CloudWatch alarms. So you can then add one or multiple CloudWatch alarms. And if an alarm is triggered during the experiment, it will stop the experiment and then roll back. What's important to think about here is, of course, the type of action we're doing. In this case, we are doing a terminate instance action. So if the instance is terminated, there is no going back.
No rollback, exactly.
Yeah, so it is actually terminated. So better make sure to have backups or whatever in place before you run that type of action, of course.
But when you say terminate, I assume that, for example, you wouldn't actually do this on a regular EC2 instance. You would do this on what we would call an auto-scaling group. So, for example, it's a pretty much stateless instance running some software. when one is terminated, another one is started instead, which would also kind of test what we're trying to do is does my scaling work? Does my application behave differently while I have an outage or whatever?
Yeah, no, exactly. And that's really one of the main use cases for chaos engineering is verifying a specific behavior. And it could be verifying that my autoscaling groups work as I intend them to. If an instance is terminated, new one is spun up and then becomes healthy and can receive traffic.
Yeah, and obviously you don't have to terminate the instance. We also have a stop condition where basically for a certain period of time, we shut down the instance and then it comes back up again, either after the time or when the experiment is is aborted through the alarm.
Exactly. All right, so with that, as you saw, I'm skipping stop condition in this case. So that also gives me alert and says that I don't have a stop condition. So I need to confirm that I actually want to create it without.
Okay.
Now with that in place, we should now be able to start our experiment. And this experiment in this case is basically checking that what happens if I terminate an instance in my environment. And since this is an autoscaling group, well, what we expect to happen is that it would then create a new instance, basically, and then get back to the number of instances we have. All right, so this is chaos engineering in practice, meaning
Live 101.
Things are definitely going to fail. Demos with chaos engineering, they are meant to fail, I think. All right, so now AWS FIS is then initiating my experiment and then walking through the actions that I've added. In this case, we have one action. So it is running. Oh, quickly completed. So that's good.
Oh, it doesn't take that long to kill an instance in AWS.
It doesn't. So now we can see that one instance is shutting down and eventually then terminating. And as soon as my autoscaling group picks up on that change, that something has been terminated, it is then going to start eventually, if my hypothesis is correct, start a new instance and start spinning that up. So that's our first chaos engineering experiment, and it's pretty straightforward. And I think a question might be then, well, I can do this myself. I can simply terminate an instance. But that goes back to what Rudolf talked about before, that this is doing it on a level that a regular customer doesn't really have access to. So it gives you these safety features built into the service.
To clarify, imagine that you wanted a developer to go and terminate an instance in production. In most organizations, that would be an absolute no-no. But now, because of what Gunnar showed you with the role, you can give a developer access to production to the one or two instances that are tagged, and then you don't worry about it. You give them a button, and that's where the real value comes in and what's hard to replicate.
Yeah, that's actually, so you can pinpoint and very, very granular give what you would like for your A/B testing, whatever else it is, to see how these kind of things can actually work.
Exactly. And yeah, we can see here that a new instance is now in the running state already and is initializing. So I think in a few moments, we can say that we have verified a specific behavior. And I think a key here is that no matter if that happens or not, we have done a successful chaos engineering experiment, because no matter what, we learned something about it. If my autoscaling group didn't spin up a new one, well, that was unexpected behavior for us. So then we learned something new, we can improve the system, and then run the chaos engineering experiment over again. All right, so that's our first experiment. And it was kind of container adjacent, because these are actually instances that I'm using for ECS. So I think we're still on topic. Next, I would like to then move into these new actions that were launched last week. So as Rudolf said before, we've now launched a few new actions for both ECS and EKS that then allows you to run chaos engineering experiments on a task level towards your tasks or pods then running in your environment. And this gives you ability to test a few more things and verify new things within your environment. So we're going to look at one of those. First off, let's switch to the EC2 console and just have a look. So we have an ECS cluster running on EC2. And it is then one service. And that service, well, I guess now we have 3 instances again. We were down to 2 for a while. So we have these 3 tasks running. They are healthy, so all looking good. So what we can do then is create a new experiment template, basically. But as a good TV chef, I have pre-prepared, so we don't have to watch me just write in the console. So what we can do is run, for instance, CPU stress on our tasks. So this is my experiment template. Let me open it up so I can show you. So I've added one action, and that action in this case is the ECS task CPU stress. Besides that one, we have a few others. We can do IO stress, we can do memory stress, we can kill process, and so on. So there's a list of new actions available for ECS and for EKS. In this case, I'm going to run my CPU stress for 5 minutes. I can also set a percentage. How much load do I want to add? And the default is 100%, so it's going to run 100% of the CPU, but I could set it to something else if I wish. And then, canceling that, I have my target, which in this case is targeting my cluster and my service. So the ECS cluster and the service. And then I can add the selection mode in the same way as before on the tasks that are matching this service. How many of the tasks do I want to run it on? And in this case, let's set it to all, basically.
Okay. So in other words, you're going to take an experiment which will load the CPU in all 3 tasks that you have running in your service currently.
Exactly. And basically see what happens to my service if that is happening. I have my IAM role, of course. In this case, I've added CloudWatch alarms. I have a simple alarm, a demo alarm, but then I also have a synthetics that's basically testing this URL for my service in this case.
Okay.
I'm not going to update it because I didn't do any changes, but what we can do is now start my experiment. And starting this experiment, firming, because this is actually happening, it is going to run these actions on my environment. And this takes a few moments before it actually starts. What's happening now is it's starting the experiment, then it's starting the action. And these actions, they are running with the help of SSM or SSM documents.
I was just going to ask you how this works.
So maybe, Rudolf, you want to chime in on the specifics of how we're using SSM in this case.
Yeah, so I don't fully know how the integration works with all of the new tasks, but in the most general sense, SSM or Systems Manager is a tool that allows you to run automation. Often large organizations will use it for patching and those types of things. And one of the cool things it allows you to do is to run code, to run scripts on your virtual machine. And so in this particular case, you're going to be targeting under the hood the EC2 worker nodes for your ECS cluster, for your EKS cluster, and you're going to be executing an SSM document, presumably one that runs stress-ng, and that will then affect the environment in which your tasks are running.
And it's actually a bit cooler than that, to be honest, because we have been able to use these SSM documents. For instance, I'm now in Systems Manager. We can see the run command part of SSM, and we can see my document in this case, AWS FIS run CPU stress. And that's a document that everyone has access to and can run. And we could target EC2 instances with this and run it. So previously, if we had ECS running on EC2, we could target the EC2, the entire instance. But what this is doing instead is that if I switch back to ECS and go to one of my tasks, we can see that I have 2 containers in my task. So I have my simple ECS sample container running, I think it's a PHP website with Apache. But then I also have a sidecar, an SSM agent, which is running within my task. And that is the agent that is then going to use that document. So we're basically using that as a sidecar to inject this CPU or this fault, the CPU stress into our ECS sample containers in this case.
So I have so many questions, if you don't mind.
Oh,
for a second.
yes.
Let's go back to what we were talking about with the tasks. Does the customer have to create this as part of the task definition when they create the task, or is this injected automatically?
No, so this is a change that needs to happen in the task definition to add that sidecar. And I guess that's something that many are familiar with other types of observability tools or security tools and so on.
Correct.
So simply adding that SSM agent as a sidecar in your task definition.
And I assume this is all documented very well. I'll try and pull up the documentation link while we're working, but I'm not sure if I'll get it. If so, give me a ping afterwards, and we'll definitely post it somewhere else afterwards, or in the show notes of the show, either on YouTube channel or Twitch, wherever it may be. So hold for 1 second, because I just want to welcome everybody that has joined our stream in the middle. We're talking today about AWS Fault Injection Simulator, AWS FIS, and ECS integration. I have here with me both Gunnar and Rolf and myself, and all yours again, Gunnar.
All right, thank you.
I wanted to add something. Sorry, Gunnar, before you go on, I wanted to add something to what Maish said. So we are also trying to make this as non-impacting as possible. So for ECS, you do have to install that sidecar, but for EKS, you don't. For EKS, for the new actions that we've installed, we create and destroy that sidecar on the fly.
Nice.
Yes. All right. So what's then happening when we're running our experiment? I set it to 5 minutes, so I probably have a minute or so left. It is then kicking off this SSM document with the help of the sidecar. And we can follow the progress simply in SSM as well, besides from in the FIS console. And we can see my 3 tasks and that it is in progress. It's done the first step, which is basically make sure that the dependencies are in place. And then the second step is doing the actual action, which is to run the CPU stress. So while this is happening, we could, I suppose, check. Let's see if I can find my way back. This is my... Here we go. So we can see a spike in CPU utilization. So that is happening, but at the same time, we don't have any alarms as far as I can see. Here we go. So the website is still responding, but depending on how we're monitoring, perhaps it has certain amount of added load and so on. This is a very, as we know, the ECS sample is a very basic website, so CPU load perhaps doesn't have that big of an impact on it. But by doing these experiments, well, we can then verify other types of behavior in our application. What happens if there's CPU load? And then perhaps also make adjustments to our infrastructure in how that should perhaps scale up, scale down, and so on as well. So that's our... Oh, it's done. That's our second experiment. And this one then was one where we're targeting a task within our ECS environment, one of the new tasks that we launched last week. Right. So I want to show another one. So once again, switching back to my experiment template. And in this case, I would like to show one that I think is very interesting, which is kill process. And that's an action where we can then, on the task level, we can go in and actually terminate a process that is running. Once again.
So before you start,
yes.
What I always say is the fact of you kind of do a, I would say not a dry run, but kind of analysis of what is supposed to happen. So for example, when we do this in a container in ECS, what do you expect to happen if you kill a process?
Well, in this case, I would expect that container to be marked as unhealthy.
Okay.
And when it becomes unhealthy, I would expect it to, well, I would expect ECS to basically start a new one.
Okay. Well, that's exactly what it's supposed to be doing. So that's what you're
Yes.
kind of checking here. Yeah.
Exactly. So I guess we'll see if that actually happens in this case. And that depends on how I've set up my demo environment, I suppose, more than anything else. So once again, we have an action, kill process in this case. And in that case, I can then specify the process name, Apache 2 in this case. And I have my targets in the same way, targeting an ECS task. Let's see. Is that correct? Yes. So ECS cluster, ECS service. Maybe not target all. Let's target 2 of my tasks in this case.
Okay.
IAM role and alarms in place. Update. And just checking that we have 3 running tasks. Oh, one is actually...
Yep, 2 running tasks. But that's okay.
We have 2. Yep. All right. So let's then start our experiment. The experiment is now initiating.
And while this is running, of course, as you said, the fact that I would say not the beauty, but the benefit of this actually is the fact that, of course, it's an API. You can run it on a scheduled basis. You can use a scheduled event to do this once a day, 5 times a day, however many as often you want in order for this continuous resilience.
Exactly. And I think that's definitely one of the beauties of it. When we've verified a certain behavior, being able to do that over and over again to actually make sure that things don't change over time. We know that we are doing frequent releases, we are making changes to infrastructure, we have drift in our environments in different ways, making sure that behavior stays the same, like you said, through scheduling, or perhaps through using it in our CI/CD pipeline. So on every code deploy, we are running these experiments again to make sure. That is...
Yeah, and Maish, if you want to share my screen there for a second, this may be a good time to talk about the meaning of continuous resilience as well. The part of the issue here is that a lot of customers I talk to, when they say continuous, they mean CI/CD pipeline. And we keep having these conversations about, well, are you experimenting? Are you running a test? Is the test now deterministic? And so I think it's good to think about the way that you progress through this kind of chaos engineering fault injection. You start with ad hoc experiments, more or less what Gunnar is showing us right now. If I poke at this, what's going to happen? Hopefully good things. And then eventually get to the point where you say, well, I know how the tool works. Now I want to get everyone else on board. So you run a game day. You pick an application, you bring all the people together, and you have a game day. And you can do that once a month or once a quarter, whatever works for your organization. And if you do that repeatedly, it's kind of a continuous thing. It's a process, and you do it repeatedly. And then eventually you might get to the point where you say, well, certain things could regress. I want to do this truly continuously in a CI/CD sense. So maybe you've heard of chaos monkeys, where you want to run something at random, let's say, at a level that isn't impacting to you. And so it's important to consider that the continuous aspect of this, what Gunnar said, your system is changing over time, your code is changing over time. So just because you're repeating the same thing over and over again, if you write your hypothesis the correct way, it's still an experiment, because you can learn new things based on what's changed in your environment.
Yeah.
And with that announcement, back to Gunnar and the experiments, I guess.
Well, the experiment is completed. So we have 3 running tasks that are healthy. So I guess it worked.
Yeah.
Let's see. We have reached a steady state. Started 1 task. Well, we may or may not have a new task running.
As we say, it's doing it live, and chaos always breaks things also at live, so it's fine.
Well, the application is working, and that's the key.
That's the most important thing,
have
actually the availability that you give to your customers and what the service you're doing.
Exactly.
Nobody cares about the infrastructure underneath. Only care about, is my application working, yes or no?
Exactly. Happy customers is the most important metric. So I want to show one more thing because I've talked about this safety features and how we can run safe experiments. And I've talked about stop conditions, but I haven't really shown how that could work. So I want to show an example of that. And to do that, well, let's use one of the tasks that we have. Let's use task network latency. And that's an action where we can add network latency to our tasks. So meaning that a call that perhaps takes 20 milliseconds, we can then add 200 or 400 milliseconds to each call. So to then, once again, see how does that affect our application. Thinking about a microservices type system, well, that could have a huge impact if all of a sudden certain services within that has added latency. It's also usually a good way of testing different types of patterns that we might have in place. For instance, if we're using circuit breakers or so on, we can see that those work as intended. So this is the task network latency action. We can add 400, it's maybe a bit much. Let's add 200. And we can then also add jitter, meaning that it's not exactly 200 each time. It is plus minus. I'm not sure if it's plus minus 25 or if it's 50 plus minus. Question for Rudolf, maybe. Then we can set specific sources for it. So in this case, we're going to use the default, meaning that all network traffic, basically. But we could set it to specifically certain sources as well. It could be DynamoDB and S3. I like those ones.
Nice.
Canceling. And I'm targeting in the same way. All right, I'll show it just to be certain. Cluster and service.
Okay.
And then we have our alarms in place. Let's start the experiment. Confirming that we want to start it. It's now going to add latency to each call or all network traffic. And in this case, as soon as that starts, it could mean that some alarms set off and so on, and that should then use these stop conditions. In this case, I don't think that's actually going to happen. So now we need to use our imagination a bit. Let's imagine that an alarm is set off. And like I said, I have an alarm called FIS demo alarm, which is a good name. So what we can do then in this case is make use of our trusty old terminal and the AWS CLI.
Okay.
So I never remember this, so I'm going to copy paste. So use the AWS CloudWatch set alarm state command. And we can basically set this alarm into the alarm state. So now we're all imagining that, oh, my application broke and something is triggering an alarm. There we go, switching back. We can see a FIS demo alarm is in the alarm state. Switching over to FIS, giving it a few seconds.
And as a result of that alarm triggering, it should, because of your stop condition, stop the experiment from running and causing more problems in this case.
Exactly. So in this case, we can see that it switched over to the stopped state, saying that the experiment is halted by a stop condition. And it's not only just stopping the experiment, it also uses the rollback behavior depending on the action that you're using. Rudolf mentioned stopping of an instance before. Well, the rollback behavior of that is starting that instance again. In this case, it is aborting that network latency that we're adding to our tasks. So it will stop running that SSM document and do whatever rollback behavior we have in place for that specific action. Cool. And this is basically a way for us to make sure that we limit, or we put a blast radius in place. So we limit the blast radius of our application or our experiments. As soon as an alarm is triggered, we then roll back that experiment.
So this gives you confidence in the tool that you have at least the off switch, and just in case you do something which was a mistake and cause too many problems, as you say, your blast radius. Exactly.
And one of the most common outcomes of doing chaos engineering, I think I can say this, is that we notice that we're missing certain types of alarms.
Exactly.
Well, then we can then do these experiments again, add that alarm, have it as a stop condition, and make sure that the behavior is correct the next time.
Yeah, and there's another PSA here. Not only will you notice that you're missing alarms, quite frequently you'll notice that you're missing metrics, because of course you're supposed to start with a hypothesis, and before you can frame a hypothesis, you have to have a metric on which to frame it. I will maintain so many transactions per second. Well, do you have a transactions per second metric? There's a good chance you don't. So you will start by creating those metrics and having a much better visibility and outcome for your business.
All right. So those were the examples I wanted to show right now. And we've focused on ECS now, but as we've said, that there are new actions available for ECS as well. And these were just some of the actions that we launched now. There's different types of actions that you can use to then make sure
you
that...
You can see the documentation, or Maish can switch to the slide I have up, which shows the actions that we've just released.
So they're pretty much the same, I think, except for something which is specific either with Kubernetes or whatever, but the same kind of idea of CPU stress, killing a process, IO stress, memory, and network, pretty much the same, yeah.
Yeah, you'll find that they're very slightly different, and if you carefully read the documentation, you'll find that some of them are not supported on Fargate, but we are trying to make them as feature complete as possible.
So I want to dive into that question a little bit more because we still have time. Why would it not be supported on Fargate? Because essentially you're doing the same thing to the APIs and you're running the same kind of thing. But what would be the difference here from Fargate?
I mean, in the end, this is a deep question for the developers, but the fundamental difference is that we have to access the worker nodes in different ways for different services. Okay. And so essentially FIS is a service, but we're begging other services to go and implement the things that we want to have implemented. And so even though on the surface it's a container running on some kind of executable, we still have to work with the service team to figure out how exactly to implement those things. And not always are things possible. One thing that you will notice is that the network actions in particular, they require privileged containers if you want to run them from inside the container. And so now, again, certain things you can run from a sidecar if it's privileged, certain things you can't. And so we're filling them in as quickly as we can, but we can't break the existing resilience and safety designs that already exist in services.
Cool. And this is, I went through this when preparing for this demo as well, and it's in the documentation. It tells you the differences, certain things that aren't available through Fargate, and also the reason why. So it's readily available.
Perfect. Gentlemen, this has been very, very interesting. And we have another, I'm going to finish a little bit earlier today, so that's okay. Give you some time back for the rest of your day. But is there anything else you would like to share before we wrap it up today? Gunnar.
Well, so I think I was going to hand it over to Rudolf to talk a bit about something that we often hear about is how do I test availability zone faults? Ooh. And I know this is something that Rudolf has been studying carefully.
Yeah, and this is a little bit to help you improve your experience, right? We keep hearing this over and over again that our customers would like to test availability zone failures, and they all expect that we could give them a big red button that says, okay, just terminate this one availability zone. The problem is that we spent a decade building extremely resilient systems. And what you need to realize is that there are two components to every system. There's a control plane and a data plane. And so when we try to affect something, the naive way would be to say, well, okay, I have EC2 instances running in one availability zone. Let's just go and terminate all the instances in one availability zone. That simulates an outage. But in practice, of course, it doesn't, because the control plane has no idea what just happened. The control plane would say, like, imagine an autoscaling group. The autoscaling group would say, well, I'm missing 30% of my instances. I'm going to spin up 30% more instances. Where am I going to do it? I'm going to do it in the availability zone that has the least instances. which happens to be the one that I just targeted. That's emphatically not what you would expect for an availability zone outage. And so those are the things where if we do it, we have to make our environment's control planes aware of the things you want to simulate. So for us, this is a very slow, careful process to not affect all of the things that are supposed to work. If you do it, which you can, and we have a good workshop on this that you can consume if you want, then you basically have to think through those details. What is the control plane? What is the data plane? And that doesn't just apply to AWS, where, in the simplistic case, you can terminate EC2 instances. That applies to your own things as well. If you're running clusters, then you will have the same kind of problem. You'll have some nodes that are control nodes that have an opinion on what should or should not be alive, and that also won't be aware of what availability zone you might be targeting. So whenever you want to have availability zone outages, my best suggestion would be talk to your account team, talk to your account SA, and get them to work with you to go and design the experiment setup that you need to simulate something that would work for your environment.
Cool. Another thing I'd like to add as well is I think it's one of the most common questions I get. So we have AWS FIS, we have our environment, and we can think of a bunch of different experiments, but where should I start? How do I get started with this? And my suggestion is always to start small. Start with the smallest possible experiment you can do to then just get used to it, get used to doing this. And that could be simply verifying autoscaling behavior, or it could be testing a specific feature in an application, and so on. Do these small experiments to basically get used to this way of thinking. And by doing that, I think it's easier to then be able to scale it from there.
And then go from there. Start this in dev test. Absolutely. Don't start in production. Yeah. We've already mentioned that what you will discover is that you don't have monitoring, and you probably have less monitoring in dev test than you have in production. So that's a very good place to start looking. You probably have less monitoring than you want to have in general. So that's a good place to start looking. And only once you're truly confident that you have clarity around what constitutes a good operational metric and you know how this works in dev test, start very carefully experimenting in production at low enough levels that you believe that nothing you're doing would at any point actually impact your customers.
And also, you always have those safety stoppers, those stop conditions that if you do actually do something bad, it will automatically roll back everything and stop the actual experiments and not cause even more of an outage.
Yes, but also, if you already know that something is going to fail, there's no point in doing the experiment. I see it quite often that you design an experiment and you straight away realize, well, if I do this, something is going to fail. Then it's better to just skip to the learning part where you learn from that, you fix the problem, and then you can go back and run that experiment.
But going on to your point, there is actually, I would think, benefiting of knowing it's going to fail, but also testing the supporting functionality around it. Did I have the correct alarms to tell me that it failed? Did I involve the right people to get notified? Yeah. Did have impact on underlying dependencies or servers underneath? Those kind of things, even though you know it's going to fail, you can also still learn from those kind of experiments as well.
Definitely. And I think that's touching more on the game day aspect of it, because that is not only testing that specific experiment, it is actually more about the things around. Like you said, are people getting notified? Does our processes work? And so on. So a game day can definitely test something failing, to then be able to make sure that all of these other things around are in place.
Perfect. I think we're going to wrap up now. I would like to thank you both for joining us today, teaching us a lot about not only chaos engineering, but how you do this in a native way inside AWS with AWS FIS. Thank you for spending your time with us. And of course, anybody who has any questions, please feel free to reach out either to me or Gunnar. You can see his details here on the screen with his Twitter handle. This episode, of course, will be available on Containers from the Couch YouTube channel. Please don't forget to hit that subscribe button on the bottom of the screen. And we will see you sometime at the end of the week for another episode on something else with ECS. So please stay tuned. And of course, if you're in the AWS Summit in Toronto, please ping me, say hello. Be happy to chat anything containers, all also anything which is container and resiliency as well. Thank you very much, everybody, for joining us.
Thank you all.
Thank you, everyone.